I'm Dylan Brewer from the School of Economics, and this was joint work with Jennifer Kaiser in Civil and Environmental Engineering and Earth and Atmospheric Sciences, and Dan Molzahn from Electrical and Computer Engineering. And we were working on a project to assess unequal impacts and health benefits from EV adoption and charging, particularly the impacts on air pollution. So our overall goal is, to estimate the impacts that EV adoption will have on health outcomes. We expect this to improve local air quality due to taking internal combustion engine vehicles off the roads. And this grant in particular was funding effort in economics to build an EV adoption model. So trying to answer the question of where and when will households adopt electric vehicles. So if we have electric vehicle adoption in urban, highly densely populated areas, this is going to actually result in more positive health impacts than in rural areas, because these vehicles are going to be internal combustion engine vehicles will be taken off the road near where there are more potential health impacts. At the same time, you might have differential adoption rates based on socioeconomic status, and so some of these benefits might be concentrated in higher income areas rather than lower income areas. So what we did over the last several months was we built an EV adoption model using data on electric vehicle registrations from really nice publicly available data in Illinois, hence our picture of Illinois up here. And what we did was we actually projected EV adoption rates into the future. The good news is our estimates are actually telling us, if we believe them, that we will reach 50% EV adoption in the state of Illinois by 2035, which is, I think, pretty awesome news. I don't know that I yet believe these preliminary results, so don't run away and sort of like tell everyone our findings just yet. But what is really interesting is actually the spatial pattern of adoption that's going to get us there. So the red colors in this map are indicating higher adoption levels. So when in 2035 we hit 50% of EVs on the road, our models are predicting that almost all of the EVs are going to be in urban areas. So this is in Chicago, in the northeast corner of Illinois, in Bloomington and Peoria and Springfield, so the sort of major metropolitan areas of Illinois, and also down where Kansas City is in the south. So what we're basically seeing is like all of these EVs are going to be adopted. All these EVs are going to be adopted in urban areas, and that's actually a really good thing in terms of health impacts. So all of the studies that are currently trying to assess the benefits of electric vehicle adoption assume an equal adoption rate across space, and all of those estimates are going to significantly underestimate the health benefits of EV adoption. Okay, so what's next? We need to add policy variables that can influence EV adoption, such as EV subsidies and charger subsidies, to the adoption model, and see whether we can sort of like influence this adoption, this like spatial adoption pattern with policy levers that we have. We want to move beyond Illinois, and we focused on Illinois because of like the great data that they have there. And we want to combine these with models of the grid and air quality that are already being used to look at the health impacts. And the thing that we really need, that we would really like next, would be Georgia vehicle registration data. And we've been trying for quite a while to get this and have not yet prevailed. But thank you very much.